In this video, we will do a probability example that involves complements. So the example says that a multiple choice exam has 8 questions, each with 5 answer choices. If you guess answers randomly, what's the probability that we get at least one answer correct? And round your answer to 4 decimal places. So this question is asking us for the probability of getting at least one answer correct. So if we use our formula for probability, we're going to set up a fraction, and on the numerator, we are going to write the number of successful outcomes. And in this case, we have a successful outcome if we get at least one answer correct. So the numerator is going to be the number of ways to get at least one question correct. And in the denominator, we put the total number of outcomes. So the total number of, and in this case, my outcomes are different selections of answer choices. So it's the total number of ways to select answers. All the different ways that we could select answers. All right, so I want to talk about 2 approaches to this. So the first approach, approach 1, I'm going to call this the direct approach. So if we approach this directly and we think about, well, how could I get at least one answer choice correct? We run into cases because getting at least one answer correct could mean maybe we get one answer correct exactly, or maybe we get 2 correct. So that would be my second case. And we could keep going like that, 3 correct, 4 correct. There's 8 total questions, so the last case would be if I have all 8 correct. And that would be my 8th case. Okay, so if I do it directly, I would have to think about each of these cases, all 8 of these. And that is a lot of cases. It's doable, but it would just be tedious. Okay, tedious, I want to draw a sad face here. So often in counting questions, if I'm trying to count something directly, and it's either hard or tedious to do, we may think about trying to use the complement. Especially if using the complement happens to be easier. So that's something that we get better at recognizing with more practice. Like, is the complement easier to compute than just doing it directly? So let's think about that in this question. So I'm going to visualize the complement by drawing a Venn diagram. So I'm going to draw a circle for the set that we care about, which is getting at least one answer choice correct. And I'm going to draw that in some universal set. So I'm going to call this U. And my universal set of all outcomes is just the set of all selections of answers. Okay, so I'm going to call my set, the circle in here, that at least one correct. I'm going to call this A. So then what would A complement be? Well, if I don't get at least one answer choice correct, that would mean that we have no answers correct. That's what the complement is. All the different ways to select answers where we get no answers correct. Okay, so let's try it using complements now. All right, so this is going to be approach 2. Approach 2 using complements. So we are trying to count the number of ways to get at least one answer choice correct. I'm going to need that for the numerator of my probability fraction. Okay. So using the complement, what I'm going to do is I'm going to count the number of things in the whole rectangle, which is the total number of ways to select answers. And then subtract away the number of elements in the complement of A. So the complement of A is the number of ways to get no answers correct. Okay, so using my set notation, getting at least one answer correct, this is what I'm calling A. Getting no answers correct, that was the complement of A. And I'm subtracting that away from the total. Okay, so how many ways are there to select answers? Well, the question said that there were 8 questions on this exam. Each of them has 5 answer choices. So that means we have 5 choices for the first question, for the answer that we put, and then 5 choices for the second question, and 5 choices for every single question up until the last one. So we'll keep multiplying a bunch of 5s, and there's 8 questions. Oops, let me put this in red. 8 questions, so overall we are doing this 8 times. And then I subtract the number of ways to get no answers correct. So if I want to get all the answers wrong, that means for each question there's one right answer, but there's 4 wrong answer choices. So I want to make sure I pick one of those wrong answer choices for each one. So there's 4 choices for the first question, times 4 choices for the second question, and so on until I get to the last question, and 4 choices for that as well. So we are multiplying these 4's together as well 8 times because there's 8 questions. And this gives us 5 to the 8 minus 4 to the 8. So this is going to constitute the numerator of our fraction. The number of ways to get at least one correct, we've said, is 5 to the 8 minus 4 to the 8. So now we got to think about the denominator, the total number of ways to select answers. But we actually already did that within this first computation. Total number of ways to select answers was here, and that was 5 to the 8. So we are ready to write out our fraction. So our probability of getting at least one answer choice correct is going to be equal to, our numerator was the number of ways to get at least one correct, which was 5 to the 8 minus 4 to the 8. We use complements there. And the denominator was the total number of ways to select answers, which was 5 to the 8. And this question said to round our answer to 4 decimal places. So I'm going to write it as a decimal, plug this into a calculator, and we get that this is about 0.8322. And that is how it wants me to leave my answer. If I did want to write this as a percentage, I would multiply it by 100, which moves the decimal over 2 spots to the right. This is about 83.22%.